Good day, everybody. So today we're moving right along to our next lesson, and our next lesson is involving solving systems of equations by a very specific method called graphing. Now, you did do this in Algebra 1, so it should be a review. And today will be a very light day. I don't think you're going to find anything too challenging about it, except for some vocab. So you got to get some vocab down. Other than that, we'll be fine. Okay, before we do that, let's practice finding the equations of some lines again. So like yesterday, this is not quite as long because the directions say find any equation. So we don't have to do all three. We don't have to do point slope and slope intercept and standard. We're just going to find any equation whatsoever. So number one, they give you 2 points. So what can you do with 2 points, guys? I love that. Let's go find the slope. So slope is rise over run, the changes in the y's over the changes in the x's. Now I'll just try to do it in my head. This y minus this y would be 8. This x minus this x would be 2. So my slope is 4. Yay. Okay, slope's 4. Got a slope, got a point. I think naturally point slope form would be great. So y minus y1. I'm going to use this point. Works for me. 7 is m times x minus x1, which is 0. Good enough for me. We'll call that good. In practice, I would hate writing minus 0. It's like, why would you write minus 0? Why would you write plus 1? It's like writing times 1. Or why would you write plus 0 or minus 0? There's no need for that. So I'd just say y minus 7 is 4x, but whatever. It's good enough. All right. Number 2 today is talking about a line passing through the points -1, 1, and -4, 4. So basically the same kind of thing. So we got ourselves, let's try to just do the slope right off the bat. The changes in the y's, right? So 4 minus 1 would be 3, right? And the x's, -4 minus -1, that's -4 plus 1, right? Which is -3. And 3 divided by 3 is 1, and a positive divided by negative is a negative, so this slope is -1. Woo! Well, again, we got points and slopes, so let's go point slope form again. Y minus y1. Which point you feel like, the -1, 1 or -4, 4? Let's do -1, 1. Okay, so the y value there is 1. The slope here we just figured out is -1. You can write -1, or you can just put a negative sign in front. That's what a negative sign in front means, by the way. It means like -1 secretly. X minus the x coordinate. So if we use the point with the y being 1, we got to use the point where the x was -1. So minus -1. Yeah, let's change it to a positive. That's bothering me. That's disgusting. Yes. Let's call it x plus 1 at the very least, and we'll call it a day. Cool. Done. I like that a lot. Sweet stuff. So there's number 2 right there on the board. All our points and all our junk. All right, last one, number 3 today. We are trying to find a line perpendicular. Oh, do you remember anything about that? Slopes and perpendicular lines, anybody? Close. Very close. Good. All right. It's the negative reciprocal of it. Right. So what's the slope on number 3? Just by looking at that line, what's the slope? -1/2, right? The negative reciprocal of that, well, it wouldn't be negative anymore, right? It'd be positive, and it'd be 2/1, so just 2. So right off the bat, number 3, we know our slope for the thing we actually care about must be 2. What the hell am I talking about 3 for? You know this thing has to go through 4 too, so yet again, this is why I love point slope. It's just so universal. Any point at all, any slope, it always works. Let's do point slope form again. Y minus y1. The y coordinate was 2 and the x coordinate was 4, so y minus 2 is the slope, which is 2, times x minus the x coordinate, which was 4. And that's good enough for me. So the direction said any equation, that's an equation. In practice, I'd probably distribute things out and get that in the slope intercept form because that's just more user friendly for me and stuff like that. But there you go. All right, here we go. LGs today, we are learning how to solve systems of equations by graphing. It's very straightforward and very easy. However, there's a lot of buzzwords to learn. So most of the lesson, and it should be a short lesson. I don't think it'll take all hour at all, not even close. I did do an 8th hour yesterday because they'll be at the assembly today. We had a good 20, 25 minutes left at the end.
On physics, if I can see they tried, they got the wrong answer, just gave them like half credit.
Yeah, like -1 or something like that. I'm kind of.
I did too.
Yeah.
It was a hard class.
Yeah, yeah, exactly. Yeah. Effort is worth something. Ta-da. All right. Don't forget your homework 2.3 over the line stuff is due today. I know there's like 5 problems or so. They're completely jacked up. So you'll get 3 points on that. Don't worry about it. I'm about ready to chuck the whole online thing all together because I'm so sick of this nonsense. But we're going to try it again. Homework 2.4. That'll be due on Tuesday. It's over today's stuff. Let's get to it. Notes, notes, notes. Today's section is section 2.4, solving systems of equations graphically. All right, here we go. First thing you need to know is what a system of equations is. You know, I just stand up here saying system of equations all day. It's like, what does that even mean? A system of equations is a set of equations. It's not one. It's 2 equations or 3 equations or 4 equations. And they got more than one variable in them. They might have 2 variables. They might have 3. They might have 4, etc. This system, usually put some curly brackets around the outside. Sometimes they don't. Doesn't really matter. But the curly brackets means nothing. It's just a grouping thing. It says, here's my group of equations. So that first one, where y equals x plus 2 and y equals 2x, that's a system of equations. The second one's a system of equations. The third one's got 3 equations and 3 variables in it, x, y, and z, but it's a system of equations too. What you're trying to do for the system of equations is you're trying to find values of these variables that make it both equations true at the same time. So this one, I think the solution in my head would be 2, 4. If x was 2 and y was 4, would both of those be true at the same time? Yeah, if x is 2, 2 plus 2 would be 4, right? And 2 times 2 is 4. It was 2x down there. So yeah, that makes them both true, right? That's great. What that means graphically, if you actually went and graphed these things, is that the 2 graphs would, guess what? Intersect somewhere, precisely. So that's what we're after today. We're just trying to solve this now. By graphing sucks, okay? That's not the best method, because you're kind of eyeballing it and you're hoping that you see where they intersect, and you're kind of, your calculator might give you some weird decimal or something like that. So this is not the best method today, but nonetheless, we will study it. All right, what could happen if you graph 2 lines? Well, they could cross at one point, correct? Okay. Or they could, what happens if they're the exact same line? Oh, yeah. How many answers are there if they have the exact same line? They would be everywhere, right? An infinite number of answers. That's kind of what I wanted to tuck in your mind for that thought. Could there be no answers? Yeah, they could be parallel and not touch, but this is more general than lines. I want to emphasize that. You could have curvy things. Do these cross? No, they don't cross. Is there any solution to this one? Nope. So there's all kinds of things that could happen. It's not just about curves. It's about everything else. But they might cross, they might not. And we have some terms for whether they might cross or might not. And this is kind of what you need to write down today. This is the bulk of your notes. These terms. Your job is to understand what these fancy words mean, but they actually mean very simple things. The outside terms, consistent and inconsistent, are fancy words for you either have an answer or you don't. So when somebody says the system is consistent, or you get out, and all it means is you got out some answer. Maybe there's one answer, maybe there's 20, maybe there's an infinite amount, but if you got out an answer, the fancy word for that is consistent. If your graphs don't cross at all, and there is no solution, the fancy word for no solution is inconsistent. So the first thing you're always going to write down is either consistent or inconsistent. Yes, Shemay. Consistent or inconsistent. Is there an answer or is there not? If it's inconsistent, which means there's no answer, there's nothing else to say. Like, well, there's no answer. Done. Problem's over. If it's consistent, there are two other smaller words that go along with consistent that you should learn. They're called independent and dependent. This is about how many kind of answers you have. If they cross at a reasonable number of spots, maybe they cross at one place or two places or 20 places. Some finite number, some number you could say, it's not infinity. That's independent. Most of your systems will be consistent and independent. Most of the problems we have, you'll get an answer, and you'll get one answer or two answers or something like that. If you happen to get answers, but they're the exact same equation, they're the exact same line, and they cross at an infinite number of spots, then we have a fancy word for that. That's called dependent. So consistent and inconsistent are telling me whether I have an answer or don't. And independent and dependent are telling me how many answers I have. Independent, any number of answers besides infinity, 4, 6, 1. Dependent is specifically for if you have the same equation and they cross at an infinite number of places. That's 90% of the battle today. It's just understanding those words. I'm gonna get your calculators out too, since it's solving by graphing. We might need to graph something at some point. After we practice these buzzwords just a little bit. So before we just dive into solving things, which is actually really easy, let's just make sure we got the vocab down. So here's a curve, here's another curve. Is this consistent? Look at your notes if you need to. What's consistent mean? It's a fancy word for, there's an answer. Is there an answer? Yep. Okay, consistent, check. Is it independent or dependent? Look at those words. Independent means it has a finite number of answers. That is one a finite number. It's not infinite, yeah. So this would be consistent and independent. Consistent and independent. That's a lot to write. So a lot of kids ask, can I just write C and I? And I'm okay with that as long as you know C and I stands for consistent and independent. All right. How about this graph? They're parallel. I'll draw little geometry arrows or something like that to show the parallel. Is this consistent? No. What's the word what's not consistent? It's inconsistent. There is nothing else to say. On your test, a lot of times people say inconsistent and independent. It doesn't make any sense. Independent and dependent is about when it is consistent. Thank you. So no solution right there. All right. How about this guy? Here's one line. Here's the other line. Do they cross? They're on top of each other, so they do cross, don't they? So are there answers? So what's the word for there's answers? Consistent. But how many answers? Infinite. So this would be consistent and dependent right there. Exactly. And so on and so forth. Do they cross? So there's answers. Okay, so it's consistent, correct? Do they cross an infinite number of places or just some set number? Just some set number. So it's consistent and independent. I don't want to beat a dead horse, but these are important terms. Do we think we got them figured out? Or at least can look them up and get comfortable with them as we go? All right, well, let's cut through the nonsense then. Let's actually practice solving some of these problems. Well, so how do you actually solve this thing? Well, the last thing you might want to write down is this little method right here to solve it by graphing. You might even want to paraphrase it. It's a little long. Basically, what it's saying is, well, there's going to be 3 methods to solve these kind of things. Today is graphing. I'm sure you've heard the other 2 and might remember them from Algebra 1. Remember substitution and elimination? Do you remember those terms? I saw a couple head nods. Cool. By far, that's what we'll be using to solve this kind of stuff in general. But If you get stuck and you can't solve it with those methods for some weird reason, you always have this one, which is graphing. There's also something by graphing. You're going to graph them. You're going to visually see where they intersect. Of course, you can't graph something unless you have y by itself. So in any, like most things, you got to get y equals both equations. You're going to have two equations, maybe three. Well, not three, not yet. You're going to have two equations. You're going to solve for y in both of them. You're going to graph it. You're going to see where they cross. If they cross, you write down the coordinate. You write down what x is and y is. You write the words consistent and independent if they cross. You graph them if they're the exact same line, then you write consistent and dependent, and that's it. And if they don't cross at all, you write the word inconsistent. It's fairly straightforward. I'll just go off script and make some things up. All right, let's look at a few examples and call it a day, because it's really not any harder than this. Here's your system of equations. Y equals x plus 5, and x plus y equals 10 or something like that. Let's write that down and let's practice solving our first system. Now, first things first. You can't graph both of these yet. Which one can you graph? I can graph this one right away, can't I? Y equals something. I can just plug in my calculator. This one's not, so I got to work for it. So let's go ahead. And how would you get y by itself? You just move the x to the other side. Okay, so I'm going to rewrite these. By the way, I would like you, I beg every year for people to do this, and they usually don't. I beg you to kind of number what the equations are. Right now, there's only two equations, right? We're building up to three equations, and the work is going to get complicated. You kind of got to keep track of what's what. So equation 1, I'm going to give it a name. It's equation 1. It's y equals x plus 5. Equation 2, like we just said, you need to move the x to the other side, so it'd be negative x plus 10. So I can graph both these now, right? So we get our calculator out, and we're going to type them in, and we're going to see if they cross. Let's see if they do. So you go to your y equals, clear out whatever's in there. Yes, there's two equations. We don't normally graph two at the same time, but that's okay. The first one's x plus 5, so you put that in y1. The second one's negative x. Make sure you always hit the negative button. Don't hit the minus button. Negative x plus 10. Well, then once they're both entered, you're pretty much ready to go. I always recommend doing a Zoom 6 to reset your window. You never know what it was last time, so Zoom standard. And here comes one of them. You should be able to graph these lines by hand, too, if you needed to, correct? Yeah, there's linear things. Cool. And do they cross? Okay, so right off the bat, what should you write down? What's the word for there's an answer? Write the word consistent. Now tell me more about the answers. Do they cross at 1, 2, 3 places or an infinite number of places? 1. So independent, right? Consistent and independent. You're going to write that for about 90% of your problems. Don't always write it. It's not always that. Okay, so we got the business done of what the solutions are. Crosses, consistent. It's independent because there's only one answer. Now I just got to find what the answer is. How do you find where these intersect? Guess where you go. Anybody want to guess where you go? Second calc. Yeah, second calc up here. Down there, option 5 says intersect. So you hit that. Now, this is not as hard as usual. It says first curve. If you only put 2 curves in the y equals, you only have 2 equations, right? Don't have to worry about a thing. Just hit enter. Enter. Second curve, hit enter. Guess, if you want to move a little close to where they kind of cross, that might be a good idea. And then you hit enter. And it just spits out the answer for you. An answer, how many different variables are in this thing? There's 2 variables, right? X and Y. One answer counts as the X and the Y that makes that true. So I only have one answer because they only cross at one spot, right? But each answer has 2 pieces because it involves X and Y. So according to my calculator, X is 2.5 and Y is 7.5. Done. That's the whole problem. Consistent, there's answers. You told me what the answers are. You told me that it's independent because there's a finite number of answers. And that's kind of all there is to that. All right, let's try another one. I'm going to make it harder on you. Not really. This isn't just about lines. Let's try one where maybe there's a quadratic in it or something like that. It's the same concept no matter what we do. There's no reason you can't do this for other things besides lines. Your homework will all be about lines, but you can do this for anything. So let's say y equals x squared and y equals 4 minus x or something like that. You're welcome. They're ready to go, aren't they? Okay, so let's plug them in. See what we get. Y equals, clear out your stuff. X to the second power, 4 minus x, zoom 6. And here comes a quadratic. That's cute. I like that shape. It's beautiful. And here comes that line. Now, how many places do these cross at? 2. Okay, they do cross. So what should you write down right now? Consistent. And it's not infinite places, right? It's just 2. So also independent, consistent and independent over and over again. You're going to a lot of those. All right, well, let's find out where they cross. So second calc again. Intersect again. First curve, just hit enter. Second curve, just hit enter. Now the guess does matter on this one because there's 2 answers, right? So somebody take the left, I'll take the right. I'm going to go close to where they cross on the right. I'm going to get an answer. Somebody move your cursor closer to where they cross over here on the left. Now I got a disgusting answer, but it's fine. You guys see what you get too. Anybody get the left one? What is it? Negative 2.56, good enough for me. A couple of decimal places is fine. What's the y coordinate there too? Thank you very much. So that is one answer, correct? That pair is one answer. You could raise a coordinate, couldn't you? X comma y. It's a point where they cross. That'd be equally valid. You don't need to do that though. My answer over on the right is a separate one. I also know that x could be 1.56-ish. And y could be 2.43-ish. Didn't even check for rounding, but something like that. That's all there is to it. Pretty easy, right? Yeah, it's not bad. All right, let me give you a couple ones to blow your mind, and then we'll see what that answer is going to be. Last couple examples. This one. Equation 1. Y minus 5x equals 2. Equation 2. 10x minus, let's make it plus 4. 10x plus 4 equals negative 2y or something like that. Really just a jacked up thing. What the heck is this? None of these are ready to go, are they? What a jerk I am. Well, let's get them ready to go. Equation 1. What do I have to do really quick to get that ready to go? Just add the 5x over, right? Okay, so y equals 5x plus 2. Sweet. Equation 2 is a mess. Well, not that bad. Excuse me. Thank you. Dang time of year. I don't have COVID. What's in front of the y? Negative 2, right? So I got to divide by negative 2, correct? Which means make sure you do it to everybody, right? Every term. So what's 10x divided by negative 2? Well, 10 divided by negative 2 is negative 5, right? So I have negative 5x's. The plus 4 divided by negative 2 would be minus 2, right? And we divided all that by that, and we get what? Y equals this. Yeah. Actually, can I go back and change the problem? I just want you to get rid of this negative sign. I was trying to prove a point, and I jacked it up. I'm stupid. If that negative sign was gone, you wouldn't be dividing by negative 2. You'd be dividing by positive 2, right? So this would be a positive 5x, and this would be a positive 2 here. Okay, sorry. What point am I trying to prove right here? What's going on right here? Yeah, they're the exact same line, aren't they? So without even graphing it, how many places are they going to cross at? Infinitely many. They are going to cross though, right? So let's go ahead and write the word consistent. Equation 1, equation 2. We massage them and turn them into this. And you don't say there's an infinite number of answers. You say the fancy word dependent. So consistent and dependent. That's it. That's all you got to say. Don't say any more about it. Okay, they're going to cross it infinitely many places. Do I need to really graph them and show you that? I hope not, because it's the same freaking equation. Okay, sweet. All right. So that was good. Consistent and dependent. There's only one case I haven't really covered yet. Let's do that one. You know where I'm going to go with this? Well, let's find out. Heck, I'll even set them up right from scratch. Nice and easy for you. 5x minus 7. 5x plus 8. Can you tell what's going to happen on this one? They're parallel, aren't they? So what's your answer going to be? Inconsistent. And you're done. You tell me nothing else. And if you don't believe me, you could go graph them, right? And I guarantee they just go up forever, be parallel, never touch, right? So what's the hard part today? Graphing it? Finding where they intersect? Heck no. It's knowing these words. So as long as you know what consistent and inconsistent means, I have an answer or I don't. And if it is consistent, I have answers. Tell me more. Is there a finite number of them? 1, 2, 20, something like that? Independent. Or if they cross everywhere, it's dependent. And that's kind of all there is to it. So nice and short little lesson today. I won't make you look at any of these examples since we already did some. And that's it. So you got 20 minutes left. That's pretty sweet. You can either finish up 2.3 or begin working on 2.4.